Let's try a proof together involving isosceles triangles. First off, we're told that segment AD is congruent to segment BD, which is also congruent to CD. Just marking those real quick, that means this segment here is congruent to this segment here, which is also congruent to this segment here. Given that information, we're going to go ahead and see if we can prove that measure of angle ABC is indeed equal to 90 degrees. That's this angle right over here. Alright, for statement number 1, let's just go ahead and say that these segments are congruent, and that's just some given information. For statement number 2, let's say that triangle ABD and triangle CBD are isosceles triangles. So because triangle ABD has these two side lengths that are congruent to each other, as well as triangle CBD having these two segments that are equivalent or congruent to each other, we know that both of these triangles are isosceles triangles by the definition of isosceles triangles. Now that we know both of these triangles are isosceles triangles, we can go ahead and say for statement 3, we can say that angle DAB, which is here, is going to be congruent to angle DBA, which is over here. And we can also say that angle DCB, which is over here, is congruent to angle DBC, which is over here. The reason why we can make both of these statements is because of the isosceles triangle theorem. So we knew this triangle was going to be isosceles because these two segments are going to be congruent. What that just means is that these opposite angles are also going to be congruent over here. Okay, that's the isosceles triangles theorem. Looking at the other triangle, if we know that this is isosceles because this segment here is congruent to this segment here, that just lets us know by the isosceles triangle theorem that these two opposite angles are also going to be congruent to each other. Alright, for statement 4, you don't have to do this personally, but I'm going to just because I think it's going to make my life a little bit easier for this proof. Hopefully it's going to make it a little bit more clear to you as well. But I'm going to call angle DAB x, which then implies that angle DBA is also going to be x because they're congruent. And let's represent angle DCB with this y variable, and so that means that angle DBC is also going to be y degrees. And for the reason, let's just say that we're defining these variables. Hopefully this way it saves us a little bit of writing and we don't have to write these angles each time and we can just use x and y for the meantime. Alrighty, next for statement 5. We're going to go ahead and say that angle CDB, which is right over here, is going to be equal to 2x. Now, how can we go ahead and say that? Well, that's going to be by the triangle exterior angle theorem. So notice that we have a triangle over here, over in DAB, triangle DAB. And if you add up these two interior angles, that's always going to equal the exterior angle, which is going to be right over here. So x plus x is going to be 2x. So let's go ahead and label that in right over here as being 2x for this angle measure. So again, if you're looking at triangle DAB, and if you extend segment AD a little bit longer here, you're going to see that this exterior angle of 2x is always going to be the sum of these other two interior angles. Alright, let's get a little bit more space now. For statement number 6, let's just focus in on triangle CDB and say that if you add this 2x plus y, or 2x plus 2y, that's going to equal 180 degrees. This is by the triangle angle sum theorem, which just states that if you add the three interior angles of a triangle, you should get 180 degrees. Next, for statement 7, we can say that x plus y is going to equal 90 degrees. And that's just because we divided both sides by 2 here, so we use the division property of equality. Alright, so I think we're getting pretty close here. We now know that x plus y is equal to 90 degrees, and we notice we have that x and that y right over here, and they do make up this angle of ABC, right? And so we're trying to prove that this is 90 degrees. Now let's remember that this x over here is really representing angle DAB, and this y is really representing this angle DCB, so let's go ahead and use some substitution and say that angle DBA plus angle DBC is equal to 90 degrees. And we're making this statement by the substitution property of equality. And then for statement 9, we can say that angle DBA, which is here, plus angle DBC, which is right over here, is going to equal what? Angle ABC. That's going to be this larger angle here, from A to B to C. Now we can say this by that angle addition postulate. And then finally for step 10, if we know that angle DBA plus angle DBC is equal to 90, but also that angle DBA plus angle DBC is equal to angle ABC, we should be able to conclude that angle ABC is indeed equal to 90 degrees. And to justify this, feel free to use that substitution property of equality again, or that transitive property of equality. I think they're both going to be okay here. Alrighty, so that just about wraps up this proof where we were given these three segments and the fact that they were congruent to each other, and we used some different theorems and postulates and other types of concepts that we've learned in the past, hopefully, and we proved that the measure of angle ABC is equal to 90 degrees. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.